Good morning, everyone, and welcome to Arbutus webinar on Simplify Your Fuzzy Duplicates Testing. I'm Zaita Dasgupta, and I'll be moderating this event. Identifying fuzzy duplicates has never been easier. Arbutus Analyzer's versatile functionality enables even new users to detect possible duplicate payments, vendors sharing similar addresses among themselves or with your organization's employees, and counterparties who may be on government watch list. Today's webinar includes 9 different scenarios with detailed descriptions of the test and their results. You will learn about identifying possible risks and learning how to deploy analyzer commands and functions. Now, before we get started, I would like to go over a few housekeeping notes for today's event. This webinar is being recorded and will be made available to all participants. During the webinar, all attendees are in listen-only mode. You're listening in using your computer speaker system by default. If you would prefer to join this webinar over the phone, just select telephone in the audio drop-down box, and the dial-in information will be displayed for you to join in. You will also have the opportunity to submit text questions to our presenter by typing your questions in the question box found in the control panel. You may send your questions at any time during the presentation. We will address them during the session. Any unanswered questions will be taken at the end of today's presentation if time permits. I would now like to introduce Michael Kano, Data Analytics Consultant with Arbutus Analytics. He has 25 years of experience in data analytics and internal audit with organizations in US, Canada, and Middle East. From 2015 to 2019, he was a senior member of the data analytics practice at Focal Point Data Risk, a US-based professional service firm. Prior to Focal Point, Michael led eBay's data analytics program in the internal audit department. During his years at eBay, Michael supported audits throughout the organization in the IT compliance, operations, vendor management, revenue assurance, and human resource areas. Michael's software experience includes Arbutus Analyzer, ACL Desktop Direct Link, Alteryx, Microsoft Access, SQL, and Tableau. He led ACL Services' global training team for 8 years. He's a graduate of the UCLA Anderson School of Management. So without any further ado, I would now like to invite Michael to present today's webinar. Over to you, Michael.
Thank you for the introduction, Zaita. Hello, everyone. This is Michael Kano. When I conducted my very first data analytics training course many years ago in Switzerland, I was asked 2 questions. Number 1, is it possible to conduct same different testing to identify possible duplicate payments? Second, is it possible to identify vendors, employees, and counterparties who may share addresses? At the time, I had to say not without some complex programming, but that was over 20 years ago, and there are now built-in functionalities that enable the average user to quickly conduct such tests. Why conduct fuzzy duplicates testing? Well, it's all about risk. We've got to document fuzzy duplicates because we can reduce risk in the areas of duplicate payments, fraud, and other control areas. So first off, fraud, identifying errors, and reducing the false positives, which can lead to greater efficiency. Let's take a look at each one. In detecting fraud, one thing we'd look for is multiple billings. It's very possible that the same vendor, either by design or by accident, could invoice you twice for the same order. Second, you may have vendors with the same address. This is a concern, it's a red flag, because it's very suspicious. Why should 2 vendors have the same address? Third, parties who are on watch lists. Whenever you transact business with a party, you may have to ensure that they do not fall under one of the watch lists. The Office of Foreign Assets Control, or OFAC, maintains a list of terrorist individuals and organizations, and the GSA, arm of the US government, has a list of people that it has transacted with in the past who have gone on to commit fraud. Identifying errors. Input errors are the most common. Inevitably, somewhere, someone has had to input the data we're processing. And it's possible there's an error made at that level. Second, optical character recognition, or OCR. This is used in scanning documents to transform the images on the documents to data that can be added to a database. Now, OCR is not foolproof. It can misidentify the letter O as a 0, the number 1 as an L, or a capital I as a 1 or an L. Another possible source of error is the lack of synchronization of multiple databases. This can occur in any organization. The larger the organization, the more databases there will be, the more synchronizing there needs to be. So if your HR database is not synchronized with your Active Directory database, there could be an issue. Finally, operator fatigue. Data input is tedious, time-consuming, and it's very possible that by the end of the day, they might say, fine, I'll just input these as quickly as possible without checking them. Reducing false positives. This means less time will be spent on dead ends. If you can limit the number of possible exceptions you've discovered to a very small number, you're not wasting your time. You're spending your time on high-value work. It increases your efficiency as well. If you can conduct more audits in a given time period, the department overall will be more efficient. This can come through automated analytics. Where you have weak or absent controls, you may require continuous auditing and monitoring. Scripted solutions allow to use complex algorithms to run against the data to mitigate the risks of weak or absent controls. Automation of best practices ensures consistency and adds to your efficiency. So once you've developed the best approach to detecting exceptions, keep it in a script, automate it, and the same algorithm will be used every single time. Right now, there are powerful DA tools that include functionality that make such sophisticated testing and detection possible. In Arbutus, we've got two classes of analytic functionality. In functions, which are part of the expression builder, we've got at least 6-7 functions that can be used to detect fuzzy duplicates. Normalize, sort, normalize, format, include, exclude, near, similar, and difference. As far as commands go, the duplicates command is very powerful with some new enhancements with different near and similar parameters. The join command can also be used in conjunction with the duplicates and the functions to help detect fuzzy duplicates. Fuzzy search functions are located in the expression builder. If you select the fuzzy search section of the functions on the right, it'll show you all the functions that can be used to detect fuzzy duplicates. For the duplicates command, it's been enhanced with the addition of same, different, near, and similar parameters. And we'll take a look at how we use those later. So when you're looking at fuzzy duplicates, you may have this sort of situation. Let's look at the top row. One database has the address on the left, let's say it's the vendors. The other database on the right could be from the OFAC database. Are these the same addresses? Well, it's very possible that they are exactly the same physical location, but you can see that they're not entered exactly the same way. So the one on the left, as far as your computing system is concerned, is not the same as the one on the right. The second address, 125 5th Street East, again, it's possibly the same address, but the text is not identical as text. And you can see in the last two examples where there's a difference of one character. There's a character missing from the address on the right that's in the address on the left. When normalizing data, you can use the normalize function against the vendor address field and reference a substitution file. The substitution file in this case, addr2.txt, consists of lists of standard address words such as street, avenue, and so forth that have been entered in all their different permutations with a substitution of, let's say, ST for street and ST for STRT. So in this way, the address on the left, 16023 40th Way South, will be rendered as 16023 40th Way S. So what does the normalized function do? First, it gets rid of all non-alphabetic and numeric characters. It converts everything to uppercase. It gets rid of any accents or diacritical marks. And then it does the transformation. So it looks up the word south in the address.to.text table and transformed it into an S. Similarly, with number 105, 1470 Boston Street, it transforms that into 105, 1470 Boston ST. That's not always enough. So there's always the sort normalize function, which does exactly what normalize does with one added twist. It sorts the components of the address into reverse alphabetical order. So 16023 40th Way South would be transformed into Way South 40th 16023. And the same transformation would occur on the second address. So even if the same address is entered in two different ways, odds are the sort normalize will be able to detect fuzzy duplicates, whereas a straightforward visual testing or literal testing would not. We'll see an example of this later when we do some transformations of addresses. So here we go. Top row is the original addresses, on the left in the vendor file, on the right in the OFAC file. Are they literal matches? No, they're not, but they're probably the same physical location. If we normalize that, we've got this transformation. Closer, but it's not a literal match. Finally, if we sort normalize, it's a visual and literal match. We can do the same thing with words. For instance, we can transform names. So all variations of Elizabeth could be transformed into L-I-Z. And the same thing could be done with male names, of course. We can also transform the names. And when you're doing distance testing to compare the number of characters in words, Rob has the same 3 letters as the word Robert. You can use the near, similar, and difference functions or parameters to test for matching based on a 1-character difference. And you can use the near and similar functions to do the same thing. The near function will look for character fields where they're within, let's say, 1 or 2 characters of each other's. For numeric fields, it looks for numeric proximities, looking for transactions, for instance, that might be within $10 of each other. And for date fields, it can look for dates within a certain number of days of each other. The similar is a bit more powerful. For character fields, it'll look for visually similar characters, such as the 1, the L, and the I. Today we'll be conducting some tests of duplicates, fuzzy duplicates. We'll see examples from payments, vendors, and employee data. First, we'll look at identical duplicate payments. Second, duplicate payments with near dates. Duplicate payments with near amounts and dates. Duplicate payments with similar invoice numbers. Duplicate vendor addresses. Duplicate or similar vendor OFAC address matches. Duplicate and similar vendor OFAC addresses based on a word match %. Similar vendor phone numbers. And similar employee names, HR versus P-card. So the first one we'll look at is for identical duplicate payments. It's always a good practice to start with looking for exact duplicates. This can narrow down the list of records to be tested for fuzzy duplicates. So in this case, we'll be looking for same date, same vendor, same amount, same product number, and same invoice number. So we have our payments. We'll go to Analyze Duplicates. The fields we'll test: vendor number, transaction date, product number, and amount. We'll send the data output to a file. And it found two. Same vendor, same date, same product number, same amount. Well, it's very possible these could have been for two different invoices. Let's run it again this time, throwing in the invoice number as a possible duplicate field. In this case, we just go back to the file, and we can run it again from the command log. And we can just add the invoice number to the list of fields. Run the test again. And this time we find 0 duplicates. So we're confident there are no literal identical payments. For the second test, let's support duplicate payments with near dates. So transaction dates within 5 days of each other, for instance, not on the same date, but just within 5 days of each other. So same vendor, same amount, same product number, and the transaction dates within 5 days of each other. So in this case, we'll run the duplicates command. We'll select the fields in the order they are above and change the last duplicate field is parameter to near and change it to 5. And select the transaction number and invoice number from the list fields list. So let's go back to payments, analyze duplicates, and we'll look for vendor number, product number, amount, transaction date. And because we selected transaction date last, it's in here in the list fields parameter, last field parameter. We can choose near and put 5. Because it's a date field, it'll look for any duplicate transactions where all the fields are identical except the date, and the dates are within 5 days of each other. We can also suppress exact duplicates since we've already tested for those. Now we'll send the output to dupes 2, trans date near 5. And we find that we've got 3 pairs of duplicates. Let's take a look at that in some detail. So what have we got? Same vendor, same product, same invoice, and same amount. Transaction date for one of them is the 18th of August. The other one was on the 22nd, within 5 days of each other. The second one, same vendor, same product, same invoice, same amount, March 1st, March 5th. And the third one, August 22nd, August 26th. So this is handy in case your vendor forgot that he'd already sent the invoice, and the same one was resent, or if they were potentially trying to conduct a fraud. This is how you detect the same payments being the same invoices being sent within a few days of each other. Now you can use the near parameter to ensure that recurring payments, let's say there are biweekly payments that your organization makes for rent. If you set it to less than 14 days, you'll exclude biweekly payments. For the third test, we'll look at duplicate payments with near amounts and dates. So in this case, the same vendor, same product number, and amounts within $10. So we should run the duplicates command, selecting those three fields in that order in the fields for test for duplicates. We'll change the last duplicate field is parameter to near and change the value to 10. Since the amount was the last field we selected, this will force it to look for matches where the amounts are within $10 of each other. We'll also select the transaction number and transaction date from the list fields list. So for every matched pair, we'll also see the transaction number and the transaction date. In the result, we'll create a filter that looks for the gap between the dates being less than 14 days. So analyze, duplicates, same vendor, same product, and amount. And here, since the amount was the last field we selected, we'll choose the near parameter, 10 for $10. And we'll list the transaction number and the transaction date. Send the output to a file. Next, we'll create a filter. We'll look for the gap between the transaction dates. We'll use the absolute value function here. Take the difference between the transaction dates, and we'll look for the gap being less than 14 days. Let's count them. And the result is 7,252 records. So we've reduced the number of exceptions we need to test. For the fourth test, we'll look at duplicate payments with similar invoice numbers. So same vendor, same product number, similar invoice numbers. So in this case, we'll just change the last parameter to similar and change the value to 1. So go back to the payments, analyze, duplicates, vendor number, amount, and invoice number. And we'll check the similar parameter, make it 1, suppress exact duplicates, and let's list all the fields. And we've got 7. Let's take a look at that in detail. So vendor, product number, invoice number. Vendor, product number, invoice number. We want invoice numbers that are similar within one character of each other. We'll select all the fields. We'll send the output. And we've got 63 records in the output. Here are 3 that are very similar. One invoice number is on the left, the other one is on the right. So 113933 is similar to 1-13933. The mistaking identity of the 1 for an L in this case, or an I. So that's true in all 3 possible matches. So this is handy. I've seen many instances where there are invoice numbers that are similar, where they might have, let's say, an A appended to the second instance of the similar invoice number. Next, we'll look for duplicate vendor addresses. Here we'll sort normalize the vendor address, referencing our substitution file, and run the duplicates command on this computed field. If your data has a zip code in it, you may want to include the zip code because there are several Elm Streets in probably every major American town and city. So let's see how we can sort normalize the address. Go to vendor master. And here's the sort normalized vendor address. Let's take a look at the formula. It's simply sort normalize vendor address referencing the lookup file, addr.txt. So just for proof of concept, let's run a standard duplicates test against the vendor address as it is. And there aren't any literal duplicates on the vendor address as it was entered. Let's test it now on the sort normalized address. And let's include the vendor number, the address in the output. Now we've got 39 matches, and they're stacked vertically. So here you can see the first example. They're almost identical, except there's a period after the avenue. You can see several groups of matches here. Some have more than one possible match. So here these 3 vendors have the same address. Let's take a look at some interesting results. The Lindbergh Boulevard addresses, all entered on the right in one format that does not match, but when they're sort normalized, there are 3 matches. The second set, the Greenway Parkway addresses, are more interesting. They're more complex. The first one has the building number, the abbreviation for East, the number sign, and then 200, whereas the second one has 200 dash the address. And how were they normalized? On the left, we see the normalized address. They were normalized. When they're normalized, they look identical to each other, and they were detected. So remember, the first time we did a literal test, there were no duplicates. Now we're finding several duplicates. So far, we've been looking at duplicates in one file. What happens if you want to compare duplicates across 2 different files? In this case, we'll look at how we compare the vendor address to the addresses on the OFAC address list. The first step is create computed fields to sort normalize the vendor and the OFAC addresses. We'll also make sure that our US addresses are only included in the OFAC data. Having a smaller file against which to run a test makes it more efficient. We'll then run a many-to-many join using the computed fields as the key fields. We'll add a filter to the join that looks for addresses that are within 1 character of each other. So we've got our vendor addresses, we've got our OFAC addresses, and let's run the join. Go to Data, Join. The corresponding file is the vendor address file. We're doing it many-to-many. And the filter will be to look for those only where the difference in the sort normalized address is less than or equal to 1. And there we are, 15 possible matches. Let's take a look at those in detail. You can see for the first match, it's an absolute match. The addresses were exactly identical. We look at the third record, 5599 Northwest 23rd against 5519 Northwest 23rd. There's a difference of 1 character. So that falls within the filter that we put. So this is a much more efficient way of identifying similar addresses, particularly when they may have been entered in different ways, perhaps deliberately, perhaps just by chance. We've seen how we can test for duplicate or similar addresses in a single file. Now, what about comparing addresses between 2 files? So here, for instance, we have vendor addresses that we want to compare against the OFAC watch list. We can also use the word match test. The word match test will calculate the number of common words between all possible normalized address pairs. It then calculates the percent match for each address, which is the number of common words divided by the total number of words. So if one address has 4 words in it, and 2 of those words match to another address, it will have a score of 50%. This will be done for both the vendor address and the OFAC address. Then the 2 scores will be averaged out to give you an overall match score. So the final output will include exact matches and all other matches where the match score is greater than or equal to 75%. So this one will be run with a script. So first the OFAC file, the address field, conveniently named address, the unique identifier. Each address in the OFAC data has its own address number. Select the vendor file. Select the address field. The unique identifier is the vendor number. And we let it run. There are 16 matched pairs. We can add the average match here. So we can see in the results the first 2 addresses, the OFAC address and the vendor address, each have 3 words, and the 3 words are common to both. So the match score is 100%. Same is true for the first 7 matches. The 8th match, they're identical when they're sort normalized, with one exception. There's one word, 45th in the vendor address, 44th in the OFAC address, that does not match. So 4 out of the 5 words in each address match. That's an 80% match. Down here we have 5599 and 5519. The other three words match out of 4. That's a 75% match. So this is a nice way of getting a more granular comparison of the addresses. It's probably best used in comparison with the sort normalized address that we saw in test number 6 to arrive at a risk score for any potential vendor OFAC matches. Next, we'll look at similar vendor phone numbers. Now, phone numbers are text and they can be entered in different ways. If we want to compare and detect vendor phone numbers that are immediately following each other, such as one ending in 7119, the next one ending in 7118, they're right next to each other. If all the other digits are the same except for the last one, we'd like to detect it. The way we do that is by creating a computed field to convert the phone numbers to numeric values. We remove all non-numeric characters, convert to a numeric value, and then execute duplicates on the new field. So if we go to vendor master, and here's the vendor phone number transformed. We can see the transformation in this computed field, exactly like the formula we had on the slide. And now we'll run the duplicates command. So the duplicates will be on the new phone number field, near with a value of 1, suppress exact duplicates, and let's just list the vendor number. Here we have our 29 near matches. So vendor 10072, their phone number is 201-948-1751. And the next vendor in the line is 752. These two vendors, they're far apart in vendor numbers, but they're only 1 apart in terms of the digit values. We excluded exact duplicates because you would presumably have already tested for those. If you didn't find any exact duplicates, it might be worth your while to perform a little bit more granular test looking at those that are near each other. Similar employee names. It often happens that databases might not be in sync as far as the names are concerned. So those could be due to misspellings, marriage status, or the default way a name is treated. So for instance, it could be von space Bülow in one file and von Bülow all as one word in the second. So in this case, the P-card list doesn't always include the employee number, just the first and last name in addition to the last 4 digits of the card. The last 4 digits of the card are not unique. So testing them against each other can lead you to identify some as being false negatives. So what you do there is you transform the names to get rid of the intervening blanks and to harmonize them into single words. So in this case, for instance, let's look at the card list. That's where we have the von Bülow name. So the P-card list. Here's Paul von Bülow. There's a space between the two. If we want to look at the P-card transactions, let's find those where the last name contains Bülow, and we can see it's all done as one word. So to harmonize these, in the P-card list, we could create a computed field. Where the last name convert everything to uppercase. and exclude blanks. So the new last name would look like that for Mr. Von Bülow. If you did this in both files, then you could do a many-to-many join, match join based on the last four of the card, the first name, and the last name new. It might be worth it also to upgrade the first name. Okay, so what have we seen today? We need to identify data where manual input has occurred or where a counterparty has provided input. You want to make sure, before you do any duplicates testing, that there aren't any anomalies that could be due to the way the data is input. You want to test those fields for consistency. You can use the format function to do that. So you can use the format function, for instance, to test to see what formats are there in the data. So here, for instance, we look at the OFAC addresses, and we have the address number, and that's how we want to test that to see, are they all numeric? Do they contain anything besides numerics? Well, we can do that by using classify. On an expression, we can use the format function against the address number and classify on the format. That'll show us that we have several formats. Some are 5 digits, some are 4, 3, 2, or 1 digit. It's important to find out if this is consistent with our experience with this data. So before you do any matching, any joining, any testing of duplicates, make sure that your format is consistent. You could do that, for instance, looking at the vendor master file. You want to see, are the phone numbers entered consistently using a pattern? So the raw phone number, as it is in the data, let's run the same test here. And we can see, we're expecting to see 10-digit phone numbers, but we're seeing a lot more that are not complete. So right away we know we have an issue with completeness of the data here. We want to make sure we take this into account before performing our tests. So let's identify the tests after that are needed to reduce the risk. Once you've established that there are inconsistencies in the data, you can allow for them in testing. So find out what test you need to reduce the risk. Do you just need a simple, straightforward address match, or do you need one that's more subtle? And examine the functionality for ways to make the necessary changes. There's a lot of analytical power in the functions and the commands. And finally, call tech support if you're stumped. We have a great tech support team, always willing to help. If you have any questions, feel free to email me. Get in touch with me either through my email or on LinkedIn. Thank you very much.
Excellent, Michael. That was a very insightful presentation. Thank you everyone for attending today's webinar. If you have any other questions, please feel free to reach us via our website, arbutusanalytics.com, or get in touch via the contact details shown on your screen. Thank you all and have a wonderful day.